Here we are on a cold, drizzly, windy morning in Red Rock. Really can't see Red Rock. And I've got to test drive this Jeep. This is a Jeep that we did many years ago and I've mentioned a few times. This Jeep's running 410s with 37s, and it's a heavy Jeep, and it has a 6-liter heavy-duty truck engine. And there's a couple of things I'm going to say about it. This Jeep was built, I'm going to say 4 years ago, maybe a little earlier, and it was using our Generation 2 electronics. The customer brought it in for the first time since the build because he thought he had a rear main leak. Well, it turns out that the crankcase was over full by about 6 quarts, so he had 12 quarts in it. And you might want to have a talk with Grease Monkey because they use 520 synthetic on a 6-liter heavy-duty truck engine. The truck engines prefer 530 on the Gen 4s. They did go to the lighter weight oil on the Gen 5s, but on the Gen 4s, stick with 530. The truck engines can run conventional, semi-synthetic, or synthetic. With the LS3 and the high-performance 6.2s, I'd stay with Dexos, Mobil 1, or equivalent. Now, this Jeep was built at a time when there really was nobody else integrating the LS into the JK at the level that we did it. Even back then, you can see we supported cruise control on the dash, check engine light. Wow, look at that, our fuel trims are running at close to 0. Like to see that. By the way, that's Bonnie Springs. Just over to the right is Mountain Springs, and that's where Howard Hughes, his ranch, was when he was here in Vegas. So, back in the day, when we first started doing this swap, most everything was integrated discreetly. We ran redundant sensors. The Prindle, for example, actually ran a switch on the shifter. We ran 2 coolant temp sensors, 2 oil pressure sensors. We ran a crank trigger wheel. And this is how we got our signals. And now, quickly, we evolved into electronic interface. And about the time we did this Jeep, I think was somewhat of the golden age, because the simplicity and the reliability of the hard sensors can really not be beat. Yes, there is some additional wiring, but it's not much. And yes, there is some additional hardware, but it's not much. So, when this Jeep was built, we pretty much achieved full functionality with a combination of electronic and hardware interface. Now, we've had the ability to eliminate the coolant temp sensor for many years, and we actually do in some of the in-house builds. We eliminated the oil pressure signal years ago as the crank RPM signal. So all that's electronically interfaced now. And this Jeep has a lot of miles on it, just like many other Jeeps we did during this era. And if everything's right, these things are stone reliable. We're moving into a new generation of electronics, and we actually have over the last 2 years, where we're using CAN technology to interface some of these signals. Is it good? Yes. Can it be bad? Yes. I'm not an expert on the CAN interface, but there is certain handshakes and communication protocols that must be followed. And one thing that you're stuck with CAN is you can transmit a packet and you can get a function to do what you want it to do, but it's very bespoke, meaning it's very limited to that function. When you look at our earlier analog digital interfaces, like the early Gen 2 MoTech module, which this Jeep has, is just very versatile. That module can be programmed for a cruise control, let's say on a Toyota pickup truck, or an early JK, or a late JK, or a TJ. It's very user-friendly. We do not have to change code to get additional functionality. We just simply reprogram the module. So it has its advantages. Now our new Gen 4 module is a hybrid. It has both CAN and analog digital circuitry, which is the best of both worlds. So we can support some things that are difficult to do with CAN. We have been supporting the Pentastar JK since 2013, and not until last year did we support the automatic air. The automatic air in the 11 and newer JKs uses a high vac controller that's CAN controlled, and we now support automatic air with the different blend door modes and fan modes, because the fan is also controlled by the automatic air conditioning. So you can achieve the functionality in a couple of different ways. The question is, which is the best way? Well, where we're moving is towards more integration from simplicity and cost, but at the same time we're not going to lose our functionality as far as being able to support multiple vehicles. We call our MoTech module a universal interface module because we've used them in old pickup trucks, Camaros, Mustangs, you name it. And it can, for example, we're doing a build right now in New York with a guy where he has a Land Rover and he wants air conditioning to work the way it did from the factory. So we're going to install the evap temp sensor and the condenser pressure sensor, and the MoTech module is going to control the system just like if it was a factory application. The MoTech module can do a lot more than that too. It can also do cruise control. It can interface with different GM BCMs and ECMs and take switch inputs from different switch gear, whether it's a Ferrari on the steering wheel or a Kia on a stock. The MoTech module will accept that signal, convert it into the proper signal for the GM side to process it and allow the cruise control to work. And that's something you don't get with CAN. You can't take, at least not easily, the cruise signal from a Ferrari and switch it into a LS3 easily. Oh look, double rainbow. No, I'm not going to start crying. Wow, it does go all the way across the sky though. All the way down there. So I know this can be confusing for a lot of you guys, how this works, and it's not magic. It's just simply interfacing via signals, and everything signal related somehow generates that signal, whether it's analog, digital, could be an AC signal, could be a DC signal, could be a discrete signal, could be a CAN bus signal, and what you do to process it is really what matters. So we are trying to most efficiently process this signal. Ah, that rainbow just disappeared. And what you're going to see next year is you're going to see we actually have a couple of CAN interfaces under development, and our Gen 4 MoTech module has had a CAN interface built into it for a couple of years, and we're now going to code that, and we're going to use this combination of technologies to get the most efficient but most reliable interface that we can get. And we're going to reduce the wire count, we're going to reduce redundancies, but we don't want to go too far. If you go too far with that CAN technology, you start to limit yourself. You start to limit what you can achieve and which application vehicles you can work with. It really is amazing what our MoTech module can do as far as interfacing. We just did a Jeep XJ, we did a TJ, we did a Toyota pickup truck, we did a Monte Carlo, we did a Mazda, and we're going to be doing a Porsche. And the MoTech module doesn't care what it is. If it puts out a signal, whether it's a square wave, a sine wave, a discrete, or a can, it's going to take that signal in and process it. So I'm going to follow up this video with some other videos showing this technology. And by the way, I'm going up this hill right now, and it's pretty steep. This is a 6-liter in a heavy-duty truck, and you notice that we're dropping gears a little bit, and mostly that's because we have the 410s in this Jeep with 37s. Now, you can see we're running pretty low RPMs, and you might notice that it'll drop a gear under a heavy load. So what you can do is you can just simply put it into second or into the manual mode, and that will lock you in that gear. We're going to have some more videos on the different shift modes soon.